So none of you have heard of this because it's a project I work on. It's a project called Serpent OS. It's a Linux distribution that's been about 3 years in the making. Obviously not very good at it because we still haven't released anything. But that's kind of where this is all leading up to. A few months ago, there was don't know if you guys have heard of Solus. It's another Linux distribution, which I may have started left anyway. Before Reddit gets on my case, I'm back there. You know, it's not abandoned, I'm back, right? They had a little bit of shaky waters, we'll say. So we thought the best strategy going forward would be a merge between the two Linux distributions, which has presented a few problems because one of them is Python, and as we all know, Python is the greatest programming language on earth until you want to do anything useful. No offense. That's just solved my LinkedIn problem. I'm not getting any more calls on that. So. The thing that was interesting to Serpent is not the distribution itself, because there's 4.5 million Linux distributions released just this morning. Nobody really cares. It's all the same thing again and again. Here's a new wallpaper. This one's got a new cursor theme. Ooh, pleasant and shiny. So it was how the distribution is built, because nobody seems to care. It's the same thing for years. Here's a package, boom, update. Here's a package, boom. The only things that have happened new, really, have been in the atomic space. Everyone's really obsessive with atomic updates. It's the new cool, it's the new shiny, but we lost a lot of features along the way. So you can have these bundles that update themselves, or flat packs or whatever, but they got massive, and there's no granularity to the system at all. If you want to install an editor, you are getting 4 desktops along with it. There's absolutely no granularity. So what we wanted to do was like, okay, would you remember when packages were actually cool before NPM just... back on topic. It's okay, I can do this. Before all of that, we had normal packages. We could use Linux systems as we wanted. We had composability. And one of the core things I find with DLang is it promotes composition. You know, it's how we put things together. This is really awkward to stand here, isn't it? Like, just there. It promotes composition, so I wanted something that would do the same sort of thing. So, long story short, it was a long story and we didn't really get anywhere. This is the dashboard for Serpent OS. It's very, very simple looking, as you can see. There is some JS in it, but it is written in D. I'm sorry, but it uses vibe.d. Adam's gonna love me for that one. It's an automated dashboard, right? It doesn't look too fancy, although, you know, we have some builds going on there. So if I quickly show you just doing a build, and then we'll start getting into the format, right? So if we go into I'm gonna do that a lot. I'm gonna go do. So I'm gonna put songs in your head subliminally, just to torture you as you try to sleep. So if we were to look in this, we're gonna use a file manager. I haven't used one in about 6 years. So this is just as much a surprise to me as it is to you. Console. So these are all the package trees. It's using a mono repo because why would you want thousands of repos? As we did in Solus recently, we had, I say we, I didn't do anything. 5,000 repos needed migrating over to GitHub. Glad that wasn't me. They have a rate limit. You don't want to be doing that stuff. So if we take, where's nano? There, it begins with an N. Okay, so these are the files. You can see some package files there. I'll get into what the packages are in a minute. Here's the main fella here. This is a very simple YAML file. I know YAML, I know. But DevOps guys, they tell me they love it and it keeps them employed. So we'll just roll with it, right? Simple key value format. This is a very simple file. You know, summary, description, here's a tarball. You can have Git things, blah, blah, blah. The main thing is we borrowed, inspired by Red Hat. We have macros, which is a simple string substitution. They get replaced with something else. The idea is having reproducible, consistent builds all the time because nobody wants to write the same thing all the time. Even to the point where I hate packaging so much, there's now a new command to take a tarball and generate that thing for me. Apparently I didn't make it simple enough for myself. So this thing here just creates a package. We're gonna go do that. This part's gonna be amusing. Calling go task, which is written in Go. Oh, that's not a good start, is it? Yeah, precondition not met, yeah, well. I didn't even want to do the talk. Right, no. Okay, so this is going to call Boulder. Now everyone knows my password. Boulder is the build tool. It just takes those instructions and spits out a package, right? Hopefully. Please work. I like employment. There you go. So that's just running the normal configure, make, install routine that you'd see with any other package. And at the end of it, you get an itchy back from the wire. At the end of it, you will get a couple of package files. There you go. Now, the only thing that's really interesting about this is automatic package splitting, because if anyone's ever had to create an RPM package, oh my God, what a pain in the arse. You have to list every single file, and then it'll fail. We didn't have those files. We didn't know where they was. You're the... No, nearly. So this automatically does the splitting based on a few rules. Automatically add ELF-based dependencies. I don't mean like hats and jingles. I mean like ELF format. That would be strange. So what we're going to do, we're going to schedule a build now. We're going to do this properly. We're going to go bump that to 15. We're going to do the build. And actually you'll notice there it's using local repositories. This thing here that's running here, it's actually creating a new route every time it's doing a build. And as you can see, it's not exactly slow. And it's written in D. It's doing, it's called MOS, because I can't think of names. And all of those packages will automatically resolve, download, cache, blah, blah, blah. They're using Z standard, but we get to that part in a bit. So we get our packages. We've had our build. And then, okay. So we got a diff, but you'll notice here, there's a binary diff. That is the thing we use for scheduling, because do not trust text files. Nobody trusts text files. Sorry, DevOps. So we get a JSON-C file because nobody could agree whether we should have comments on JSON or not, because that's why we can't have nice things. You can tell I have like a really jaded history with computing, can't you? Like, whew, how many passwords is there? This is why nobody likes Linux. Oops. I'm going to be on Reddit again. Okay, so we push the thing. All you do is you just push the diff. So on this side, this is the dashboard. There's a few components to it. Summit is the web thing. They tell me I have to use React.js now. I don't know. So we're going to split that because guys don't like to code. We're going to keep refreshing it because I don't know Ajax. It's true. We're going to hope it works now. Come on. Okay. It may be on a 30-second timer. I promise this works. I've done this before. Employment opportunity. All right, let's refresh that. Okay, so we're building that, right? So, as I said, there's a few components to it. I didn't name any of them, apart from Moss and Boulder. Boulder's the build tool. Moss is a weather reporter, apparently. Okay, so Moss will install the packages. I'm still doing the hand thing. Moss will install the packages. Boulder will generate the packages. Summit is the dashboard. Then Avalanche, you can tell we made this really complicated, right? We saw money down the horizon here. Avalanche is the thing that calls Boulder. It's just a web service. Apparently they call them microservices now. It's not, it's massive. Okay, so that's completed the build. What I actually did is that ran through Avalanche, that did a build. That then got through one of these builders. I don't know which one. One of them, right? They are in Denmark. I think I've just woke up one of the team members. It's in his front room. From there, once that build is done, that is then sent to another endpoint, which is called official, because I don't do descriptions. And where that's actually turned up is, if I can remember the URL. I'm not going to ask you guys if you know, because you don't even know what this project is. What was it called? dev.serpent.os.com. Okay, so everything goes in here. And then if we go to Nano, it's just like a normal-ish looking repo. Yeah, there we go, modification date, and those are the months prior to the Depression. So we've got a lot of packages there, right? It generates an index file. Now, it uses a binary encoding for that file, and contrary to some compiler developers' beliefs, endian format is important, even if you don't write a compiler. So these will work basically on any machine. So if I can show you the insides of one, I really don't want that rebel, do I? All right, where's the file? So we're going to do a MOS inspect on a Nano, blah, 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 right. This is why the format's mildly interesting to me, mildly. Everything is split into multiple payloads. It's got a header at the top that says how many payloads it's got. Within that, everything, this is really echoey. I have to talk lower. It's giving me a headache. So you have an index payload, which gives it content addressable storage inside every package. So we deduplicate across all of the packages. And then once we have those packages, we deduplicate, I'm not going to use that word again, on the operating system itself. So if I was to set up a root just to demonstrate, we're going to show how MOS itself works. The idea eventually is MOS will not just be Linux specific, it's going to specifically point its middle fingers at Nix and Homebrew. So we want like user mode stuff without having to learn a new programming language to install your system. So let's do, we're going to call it Bob, because I have no creativity at all. dev.serpentos.com/, I've done this before. 1 second. Volatile, x86. There we go, right. Volatile, x64, Okay. So we're going to add a repo to it, and then we're going to do a tree for that root, okay? So we've got a few directories there already. Everything is serialized immediately into a database because it turns out processing XML files is stupid. It's slow. So just dump everything into a database. So now we're going to install a bunch of packages. I'm going to go, okay, must install to that root, and then you see it doing the downloady stuff and proving it's actually a package manager. glibc sounds kind of handy. Let's give it nano vim, I don't know, systemd, util linux. That do for a minute, right? So as you can see, the dependency resolution is like really, really fast. Let's hope the internet is. So that's created a new install route there, which was, you got faster than that than me. So we do another tree, you're going to see how it's actually working. So when MOS installs to your file system, it creates a new transaction every single time it runs. So instead of manipulating the tree, removing files, renaming them, it avoids all that stuff because that is hard. Basically, doing things correctly never works. And anyone remember Steam? When it used to remove all your files, yeah? But don't do that. So we don't even remove anything. So you've got a new root directory every single time. So if I go into MOS, no I won't, I'm going to root. It looks like it's a normal tree, the user tree. But if we go into MOS, root, we have a staging tree. So the entire file system is built every single time you do a transaction. Then it activates it by using a rename at syscall. Basically, it atomically swaps two directories. So if everything was running, it doesn't crash, because apparently not crashing servers is really important. Who knew? But the nice thing is everything's I hate that word. Everything is shared across all transactions. So if I go back out of here, you'll see the store, which is called assets. Why is it called assets? Right, so if we do a tree here, you can see every single file that's going to be part of that system is just stored as a hashed blob. We actually use XXHash because it's fast, because nobody likes using SHA. Internally we use XXHash as well, and Z standard for everything, just to make it really, really fast. So it'll hard link everything into a new file system transaction every single time, which means you don't have to patch every single package in the world to work with your weird build system. So if you've used Nix before and you're trying to make it stateless, or you're trying to get it to work with anything, there's no path mangling. Everything is a normal path. So you will have like user bin, like as you would expect, but everything's hard linked, deduped, blah, 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 blah. Getting past this part, is there any questions so far about any of this crap software? Make it a bit interactive, like, I don't care. The problem is, I started writing this when I first learned D. Now, I'm not saying I'm any good now, but I wasn't then. Not even slightly. So we can look at some of like the old code. You got a question? Crack on. Just get me out.
So this is basically Nix, but
done right.
Easier? Yeah, and done right. Okay. Yeah, that's really interesting.
Yeah, Nix is great in principle, because I know I'm going to get trolled for this. Nix is great in principle. Unfortunately, in my opinion anyway, they made a few design decisions. One was requiring like a domain-specific language even to interact with it. Like nobody actually knows how to use it apart from about 3 people on the planet. Everyone else just copy-paste everything, right? So having a format that everyone's familiar enough with, I mean, this is basically an INI file, let's be honest. Like, you know, there's nothing fancy about it. If you can't do that, you probably shouldn't be using a laptop to do packages. The other thing is the mutation of the file system is something that never really made sense to me. Now, in the original versions of MOS, we used a symlink, which seemed great at the time. So /user would be a symlink to like the first transaction. But then it was getting encoded into all of the builds, which meant it remembered where it was built and it remembered the transaction IDs and it got stuck. So there was potentials there for security issues. So yeah.
It's not ASCII, so it's already an improvement.
Yeah, I mean that's definitely one way of putting it. Yeah, I mean it started out it was just going to be a package manager, and then people was like, yeah, but all these things are broken with Linux, and then like, why didn't we fix these? And why do files get shipped for configuration in upstream packages? So I was like, okay, let's just make this really, really difficult for ourselves and forbid shipping any files outside of the user tree. It's absolutely forbidden. So that by removing support in the file format in MOS, it will absolutely forbid it. Every path is assumed to be prefixed with user anyway. So everything that works on a /user tree. You can't ship var, you can't ship etc. That means some packages you're going to have to patch up in our upstream to make sure they work in the absence of configuration, or if not, a decent configuration. So if we ship a change and you have a change in your system, we ain't got to fight about it. Just make your stuff, make your stuff work, and then we won't touch it. So we're just the binary upstream distro, and things should work. So if you wanted to do a factory reset, just delete etc, bam, it's gone, start again. That's to me how it should work. It also means you can create situations where you can do a little bit more testing. So because there's no state and it's user bound, you also have this interesting situation of stuff that actually needs a pre-baked state has to work before the user gets it. So then you get into this need in triggers. So instead of every single package having its own little trigger and it's all unmaintained, whichever, it's centralized. So the idea is probably going to be something like a JSON or a YAML file that will describe the trigger to run. That would be the action to bake the system. We'll do a test boot before swapping the root over. Because the cool thing about sharing all the files, now I'm going to try using that word now. The cool thing about sharing all the files, you can roll back. So we can have a boot time support that if something went wrong, God forbid we pushed a bad update, well, you just boot back to the last one, it's still on your disk, you know. And because you haven't got to worry about the differences in state, don't know what the leg's doing there, don't mind it, then it should all, in theory, just work. Don't hold me to that. It might. So yeah, that's basically, in a nutshell, it's not really that interesting, is it, to be honest with you? You could have all been down the pub. Here I am talking about packages. But yeah, we made some mistakes along the way. At some point, I got really upset with the idea of exceptions. Really, really upset with them. So I was like, okay, let's not use exceptions. Let's instead use sum types. Spoiler, don't. It hurts. So we did try it. I'll even show you the extents we went to. It was stupid. It really was stupid. If I go to, yeah, we've got like a whole core library, we've got an LMDB wrapper, we've got a dependency thing. At some point I'd like to abstract parts out of it so other projects can borrow from it, like when the code's actually not embarrassed. Okay, shit. So if we go into core, and you can see what I mean about the error handling thing here, right? Yeah. I mean, why would you do that, right? An empty struct for success, yeah? And then we have typed failures as well now, because inheritance has not been invented yet. And then we have fail functions, because why would you not? Why would you not do something like, I don't know, enforce a condition? So yeah, there's a lot of jank. It's that bad we have unit testing on errors. It just doesn't make sense. So all of this is not very idiomatic. All of this stuff is going to go. The absolute foundational libraries will just use results. So like there will be, I know we don't like it, but it's going to be a better C library for dealing with the format itself, allowing any other tool to go into it. But everything else is just going to use exceptions and enforce, because at the end of the day, the entire standard library is built around exceptions, right, not avoiding it as far as I'm concerned. We're stuck with it, do it properly. Any questions on that while I find something else to look at? No? Right, we all agree it's crap. Right, cool. So it's got a dependency thing that's just used in DAG, basically. It's got a unit test as well. I used to do those. Even used classes at one point. Yeah, actual classes. Might go to Moss itself. Source. Okay. So as you can see, it doesn't lead to very nice code when you reinvent errors. And at some point, we started throwing errors when we dealt with our own errors. Yeah, I'm just giving the Irish a bad name, really, and let's be honest. So the plan is basically to get rid of all the crap. Now, we even have a result type, and then we're still doing enforce and exception. So the plan is basically to redo most of it, and it's going to be under the Mozilla public license because, you know, patent protection. We'd like, having done what we've done now, knowing a lot of the old code is very, very janky, don't get me wrong, but having a target now and I wouldn't even call it a prototype, to be honest with you, because then that infers some level of pride, which isn't really there. So we're going to redo it. It's going to be nice. It's going to be clean. Our question then becomes in Serpent land, because it's mainly in Serpent. Solus is still going to be like a user-facing distribution. Serpent is to be the upstream doing the 2D type things that we like, so it's like a nice relationship. How do we then use that to further D? How do we help D-Lang? So what can we do as a project to be a little bit more responsible, apart from, you know, having fights out in the streets with Rust developers? You know, that just seems a normal thing to do. How can we help further things along? Because if we don't, we're still going to be having the same conversation internally that we do all the time. Shouldn't we just rewrite it all in Rust? And that happens quite a lot, and trying to explain to people why you would use D over something like Rust. I mean, a good example I can think of immediately, we had the problem that in the Solus code base, which is old and horrible, it's really bad. It was my code. Like, we had a Python package manager, and at the time it was the greatest, it was the hottest thing about a decade ago, Python 2. And then they did this thing where they changed the Unicode implementation, and then it broke every single thing on the system because it used relative import. So at runtime, it was trying to import itself, and it broke. And we kept using it. Didn't learn from that one. We kept it as Python 2. So now we're in this position where we're trying to eradicate Python 2 from Solus because it's dead. And we come up with the idea, well, what if we just encapsulated it? What if we reduced that surface area to the point that we can get the Solus tooling using the Serpent tooling? And I did open a window, I just can't find it. There we go. So, being inventive with names, yeah, there's even stuff like Rusty Moss. That was a test. I had to do it to prove it was crap, okay? Don't hold it against me. Okay, so somewhere here, I'm really, really bad with naming. Right, DO package, okay? So this is a good example of why you'd want, in my opinion, why you would want to use D over anything else. So we go into here. Okay, this one's not a good example, actually. This is a terrible example. Don't use this one. This is a quick little wrapper around SQLite. So this here, it looks very innocent. It looks like normal code. You would probably ignore it most of the time. Some of you have probably already seen that it's using PyD. Now, PyD is a very, very interesting project. It also lets you do things that you shouldn't really do. The problem we were having at first, we directly integrated PyD, and that was cool. And I don't know if you guys are familiar with PackageKit. It's an abstraction layer for Linux. Linux loves abstraction layers. It's an abstraction layer for an abstracted plugin, which then runs over an abstraction over dbus. So that seems efficient. So we had to write something to integrate it so we could work with the GNOME desktop and such. Now, when we first did this, every time we listed 5,000 packages, we leaked 300 megabytes. Every single time. And I don't mean like just, oh, like there's 300 megabytes memory usage. I mean like 40 seconds later, where have 16 gigs gone? Nobody knows. So then I thought, okay, I've been working with the Mozilla guys for a while. What would a web browser do? Forget it. Fork, leak it, who gives you? Who cares? So that was the strategy I went with, because that's basically web architecture 101. You run a new process, Don't clean up, let it die. It'd be fine. Let the kernel deal with it. And that's what we're going to do here. So this enumerator here, again, it looks like normal code, but it's actually not. We're using a walkie-talkie. Yeah, we're using a walkie-talkie, which is just a socket pair. Didn't want to use the one in the D standard library because it's implemented as classes for some reason. And this being a C plugin, no, it's a D plugin masquerading as a C plugin that forks itself and then pretends to be Python. This is why you start with the architecture document. You don't go straight to the implementation. So I done made a goof there. So when it runs via fork, which is actually really easy to do because we created a call, run forked. It turns out, like, in our minds when we was implementing this, I say our, it was me, there was nobody else. I talked about it a lot. Nobody replied. We automatically had this idea that it wasn't going to work. It's D, it has a runtime. It's a big runtime. You run fork, nothing's going to work. How would it work? It's got its own thread management. It's got GC. That'll never work. Turns out, it does. Who knew? Not me, obviously. I had to do this, didn't I? So yeah, forks itself, creates a socket pair, and it communicates back using JSON, which sounds, no, that really does sound stupid. But it's using the ASDF library, which is freakishly fast. And it's also the only MER library that I can understand. It's true. It's literally the only one I can understand. I spent about 3 days in the other one. I was like, don't know what it does. Just code. So I made this one work. Thank you, MER guys. I don't think they even wrote it. I think that's why. So, yeah, it gets rid of the whole problem. Now, how would you even start to do something like that in Rust, or even C, in an idiomatic managed fashion where you know it's not just going to blow up? Because it's also returning a nice little range here. How would you even start to do that? Because just by using mostly built-in primitives, by using functional styles, UFCS, which I've learned has got nothing to do with fighting. Took a while. We've ended up with something that's more efficient than C. But D is not supposed to be more efficient than C. D is a big, heavy Java type thing with a GC, right? We can't use that thing, even though the internet's literally running on a GC. JavaScript, right? Everything is a GC, and everything behind it is Java. So, but everyone has a problem with D because it has a GC. It doesn't make any sense. Lots of languages have it. And then everyone says, we should change out our GC, and we should use, I believe it's called BOEM, is it? I think our one's based on that anyway, so what does it matter? So I was like, you know what, forget it. We're going to do it in a nice idiomatic way. And it does, it works. I should probably demo that, because I could be talking crap and you wouldn't know, would you? Could be, you don't know, do you? So we ain't done this for a while. Package kit D. Demo gods. What happened to you? Why is it not there? No such file or directory. Right, so that's my big bugbear with LDC and D in general. We get a new update. Breaks. Because that is going to be a linking issue. And it is a little bit of an issue. So if I go to the package, what? How is it tab completely? It's there. What? This is why people prepare. Right. It is there, but it's not there. But it is. Okay. We want this. We want demo that. We'll reinstall that. So one of the problems we've had is in terms of shipping stuff in the repos, dynamically linking the Phobos and D runtime libraries would be great if it didn't break every single time we had a release. If the SO name changes, therefore we can't link it. And that gets us into another problem. We can't dynamically link Phobos. Therefore, we're static linking everything. The binaries are fatter. As a demonstration of using D, we're kind of giving D a bit of a bad name because it's like, why is everything fat? What is this, Go? It's true, they're massive. There's even one called Micro, and it's about 10 megabytes. I never understood that one. So we have to statically link everything. The problem is if you start statically linking everything, you then can't have dynamic plugins because you can't have two versions of the runtime in the same address space. They start fighting each other. And then that's when we start getting into when UFCS is fighting. That's our bugbear. So we're going to try and get this thing working. It's probably because this is not, yeah, that would make it, okay, so we'll do dub build. Did we do dub for this one? We did. Oh. Ah, there goes Mer. Ye who is not understood. Yeah, so deprecations are a thing, right? Oh, we're working on that. Okay, cool. Stu, we're going to try and start that thing again. Okay. There was another thing as well, because Python is so chronically slow. No, it is. There's no getting around that one. Like, it is painfully slow. So to enumerate the way they implemented this, they thought, we'll use XML for everything. What could go wrong? A lot. When you try and load the information for those 5,000 packages, it then has to go through all of the XML at runtime and hand it over. So on this machine, it takes 5 seconds to actually enumerate that information, which is unacceptable if you're going to say, what packages you got, mate? Nobody wants to wait 5 seconds. On some machines, it takes about 10 seconds. But we use D. We know how to hack things to make them look like they work properly. So what we did is dumped it all into SQLite database, and then DConf, get packages, boom. Right? That's kind of fast, but it's D. D can't be fast. So there's all of the 5,000 Solus packages, or however many it is. I really don't care. It just lists it. I don't care about packages. It's really weird. I've spent the last 3 years working on it, multiple distros, and I hate packages. And do you know what we need? Another package manager. It really is. It's punishment. So yeah, boom. That's it basically. So I think that's a nice little demo showing how fast. Now don't forget, that's happening with JSON. It's magic. It literally is magic. So when it loads it up, it's using JSON to stuff it all into that database. It's going, you're going to leak like a relinquish yourself. All the data comes through. It's basically piping it back to itself. It's leaking over there. Yeah, you're going to use all of the RAMs over there. That's fine. Stuffs it into a SQLite database, which made very, very easy to use because it's D. And then everything else is just, boom, fast as you get. Which, you know, it ain't going to do anything different. If I keep pressing that, it's going to do the same thing every time. If you was hoping that it was going to be like something different, bitterly disappointed. I think that's it. Most of the toys, real-world projects that I have to show there. Any questions about any of it? These questions can also include, why? What do you do in my life, mate? Please don't be that question.
I just wanted to note the first demo you did was showing, you know, like installing packages into a new route, right? And there's a lot of work in that.
Oh, I can walk.
And
I thought I was
it
worried
works. And it worked really fast. And then when you went to rebuild your code just then and you run dub.
Yeah.
And dub was doing a lot less than what your code was doing. It took a lot
And it took a long time, didn't it? Yeah. I'm not going to shame any projects here, but you know, could be better. Yeah, I mean, I'd like to get some of the code in a position where it can be shared. So there's a YAML file. I've got to show you this because it kind of opens up the doors to what I want to do. So there's a data directory, and then there's a this, and then there's a that. Oh, God. So we go to base, YAML, keeping DevOps employed since forever. So this is the base script that's added every time it generates a script from that YAML. So you had that like the little percent thingy, and it does like a configure or whatever. Every time it's creating a temporary script, but that runs in that new route using something called Moss container. I've really got to work on it. We need a PR guy, to be honest with you, like, or anyone with an understanding of a dictionary would help. So it puts a script at the start of it, sets things up under Moss container, which really is just a Linux namespace. It's not fancy. As you can see, we've got recursive substitution, which everybody loves implementing. It's horrible. Then we have tuning groups. So these just say which named flags we want to enable. And they're kind of handy, not really just for packages. And that's sort of the point I'm getting at. Because all of this stuff here, say we handle C flags, CXX flags, LLVM versus GNU. I hate saying that. This could be useful for other stuff, not just us. And I think that's what I'd actually like to do. If we could take the core parts of Boulder. Oh, here's the automatic package splitting as well. Yeah, take that RPM. They literally can't do that. You have to define every single file. Why? Just dump in one place. I dealt with it for a while. It was an employment opportunity. I left. Yeah. Oh no, it was fun. So if we could take all this stuff, rip all the core stuff out of Boulder, write it in a way that is significantly less embarrassing, then share that for other projects, because at the end of the day, everyone's creating new package managers, everyone's creating new build tools, and none of them are really that great on their own. You know, because they have to do so much. They're reinventing things that have already been done. Says me on stage talking about a package manager. Irony. So we could split it out into nice reusable components. Give it an external C API, whatever, right? But make all the nice stuff in D, yeah? We could have like a poverty API for the other guys to hook into, yeah? So they're like, oh God, it's like crack, I need more. That was appropriate, right? If we could share all this stuff, would there be interest in reusing these parts for projects like Dub? You know, like the dependency stuff, we could fine-tune it, share it between the projects. Because Dub is installing packages, we're installing packages. Dub is building stuff, we're building stuff. So why not reuse that core and share it as the basis of multiple tools? I think, personally, that'd be something I would be interested in, but it depends if you guys want that, or you want your really slow build times. Up to you.
Yeah, I use Arch, and
By the way.
and I feel like when I want to build a package manually, because the package manager to build packages on Arch is purely Bash. It's all made in Bash.
Big package, yeah.
And it's kind of painful, so I wanted to switch to Nix, but Nix uses Haskell to... so this seems a good alternative to explore. One thing that I wonder is if I can install packages per build or build myself selectively. Can I do it?
What do you mean? Sorry.
So, like, imagine I have a libc and I want to build myself, but some other package like Blender I want to pre-build. Can I do it? Okay.
Yeah, so another thing that was really irritating, so we learned from having the most horrible tooling ever, thinking it was great. When you live in that bubble long enough, like as you come out of it, it's like, oh my God, get me away from it, never go back there again, never go back there. But you remember all the stuff that was horrible about having to maintain with it. One of them that I found kind of with a lot of distributions as well, not so much RPM based, but basically everything not RPM based. Having local overrides on your system is incredibly difficult and incredibly frustrating, and I don't think it needs to be. So having local repositories was one of the first things that we ever did, and it turns out it's really easy indeed. If I can find that precise example.
I can share your frustration on that, because I have a local repo of Arch.
Yeah, Arch's tools are how do I not end my career here?
Yeah, I understand.
Challenging.
Yeah.
So I'll quickly show you the way it works from the core part, right? So he's trying to get me off the stage there, not. I've seen that. We have a library called libmos. The dependency stuff is kind of old. Obviously, we have
Also,
a diagraph.
don't worry about naming. You are good at naming, I guess.
Yeah, I mean, years ago I was creating a media player. And I was like, what will I call it? I Googled and I was like, Songbird is taken. What will I call it? Budgie. What could be an irritating other noise, right? Budgie. But then at one point I was like, I don't really want to work on this anymore. Wouldn't it be great if I had my own desktop environment? So I literally took the name off it and gave it to the other one. So it went from budgie music player to budgie desktop. And
When in doubt, you just call it
reuse.
sound player.
Reuse, yeah. We've got a module here called Fetcher. I had this great idea. I was like, curl is the greatest project in the world. It's nice. I'm being very careful here. It is a nice project. However, using it from D, there's no real nice way to have things like coroutines. So I was like, okay, what we're going to temporarily do, and I do mean temporarily, is use VibeD and just make life easier. There's a couple of things that would make life easier for us in general. I think having a native TLS implementation would make life for us all easier. Not having to link to OpenSSL all the time. Not having to link out to curl for things as well would also be great, because the fewer C dependencies you have, the easier life you get, and then the more cookies you can have. It's true. Yeah, there's an analysis thing here where we actually do parallel analysis of all of those files. So when it does a build, it's not just like, okay, let's just make those into a package. What it does is a chain on all of them. Well, this thing wasn't written the greatest, but it bucketizes everything. It will scan everything for a hash. It will look for the alt magic. It will extract all of the used zone names, all of the exposed zone names, and it will use those as part of the dependencies for all of the dynamic libs that's used. It's automatic. You could have had that too, Arch. They didn't. So we automatically add the interpreter paths. The build IDs are automatically handled as well. So we know everything that's gone in there. We have their hashes. The whole, it just works at the moment. So what I was actually looking for was in a transaction. Might be in here. I think it's in the manager. There's a multi-sort somewhere. Nope. Sorted registry items. Nope. 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 Oh yeah. Shuffle plugins. Literally a thing. Shuffle plugins. Okay. It just gives it a priority. I mean, it's that easy to do indeed. You just resort it in place. There's places we use multi-sort as well, which I'm trying to find and I can't find. Oh right, grep, that's the thing, isn't it? The Linux guy doesn't know how to use Linux. CD projects, and then we're going to use rip grep, rather than rust. Multi-sort, there.
We have to create the rip grep.
That's not even my code. Okay, we did use it, it's gone. Just imagine we did, and how cool that would be. Yeah, there's only, I think, a minute left, so if there's any last questions or requests that we make ourselves useful in the D community, because we just sort of sit on the sides and complain a bit, to be honest with you. It seems to be our thing.
I just wanted to comment and make, to tell you how...
Here, let me come over.
How short the functions are. I really appreciate that. I could see myself understanding this code.
Yeah, I mean, that's one thing I hate as well. Do you know when you have like thousands of lines of code in one file, it just gets really, really horrible. So I mean, one of the efforts that we're working on now, quickly show before I get chucked off the stage, which is probably overdue, let's be honest. Lipstone, where's Lipstone? No. So we started a project. I haven't really done anything with it yet, but as I was saying earlier on about, that's not how you open things, is it? Oh, what? I thought it was a file chooser. All right, just a quick example. So things that I like about D is being able to do things like this. Now, it might look ugly, but aliasing a type to another type and then giving it methods, I think is just absolutely brilliant. So here, we're defining the file header. It literally is just a 32-byte thing. That's stuff that I like. And then we can have a V1 header, which extends it with more data. It's still the same thing, but now you can cast it. So we'll have an agnostic way to always be version safe going forward. And I think doing this in other languages, it's a massive pain in the hole, to be honest with you. This is no way to put it. So, right. You've been great and I've been awkward.
Thank you very much. Nice nice shallow question, but what motivates you to actually do this?
Anger.
No, genuinely, because like you'll have
Anger, genuinely anger. Dealing with other formats for so many years. Why do you do this? That's all it is. This is rage code.
Not temple building then.
No, it's... I don't know. That's literally what it comes down to. I'm just angry at the other solutions because why do you do this? Why do you do things stupid? Why aren't you better? And that's what it comes down to. And even my own solutions I've written before, it's like, ugh, why would you do things that way? So that's kind of what it's about, engineering a better solution. But that's what it all comes down to. It's something that is going to last for the next 20 years or whatever. We had a slogan with Solus. It's, if I can remember it, install today, update forever. It's a very bold claim. It's bullshit. Because at some point something is going to break and it's going to be the package manager itself. And that's sort of where all these efforts focus around. Knowing at some point, you know, there's a termination point for how useful that package manager can be. It's stuck in Python 2. All of the surrounding tooling is then bound to Python 2 as well. So that's part of the inspiration. And just doing something the better way, because like so many projects have such great potential, but they're just landlocked to a specific way of doing things. Ours is the better way. So me always being the permanent outsider, I'll do it my way. And then I will laugh at you. And hopefully this time we'll actually have something that we can share with other projects. So I think one of the common complaints about D is dub. Now, dub specifically, there's nothing really wrong with it. It's nice. It could be faster. It could be more efficient. It could cache things better. It could build things better. It could make LTO easier than other package managers. But why reinvent all that code? So in my view, why not just take our code once it's cleaned up, stick it in there, and then, you know, Rust.
Yeah, I think we're done.
All right, nice one.